This is a number, this is a number, this is a number, this is the number. What? Okay, backing up.
Okay, where came that sign?
This is the left-hand side, this is the right-hand side. So I just filled in sine alpha, cos beta, cos alpha, sine beta. So right from the pink card. Okay, so look at your pink card. You're looking for sine alpha plus beta. This is the other side. See it? Okay, so these are just unit circle values. So sine of pi on 4. Root 2 on 2. Sine of the pi on 3 family. Two pi on 3 is in what quadrant? So cos is negative. Cos of pi on 4? Sine of pi on 3? Two pi on 3 is in what quadrant? So sine is positive. This is a multiplication, that's an addition, this is a multiplication. What do we have to do first? Do you see how every question we've done the multiplying first? So top times top, bottom times bottom. Or not. Second fraction, top times top, bottom times bottom. Do you hear music?
Yeah.
Oh, it's her phone. I didn't know where it was coming from. I'm like, what is that? That was very Arabic. I like that. Keeping the common denominator, smushing the top together. Doesn't that kind of look like our last answer? Why does it look so similar? Because it's the pi on 12 family. This is just in a different quadrant. What quadrant would 11 on 12 be in? We now have had all four as answers. Let's think about it. This is n minus 1 over n. It's quadrant 2. But that's not what the question asked us. What did the question ask us for? Cosecant. How are you going to find the cosecant? Flip it. You don't have to rationalize, you just leave it. That is the cosecant of 11 pi on 12. The reason they don't want you to simplify or rationalize on the exam is because if you do it and you do it wrong, we have to take off marks. And rationalizing isn't an outcome in this course, it was an outcome in grade 11. So we teach rationalizing because university will rationalize and they would never let you leave an answer like this, but the exam doesn't want to punish you if you don't remember how to do it. So you can leave it, you can rationalize if you want to, but if you do it incorrectly, we have to dock marks.
Is that just bulk test?
All radical questions. All radical.
So you can't just write the answer and then rationalize it and write down, you can't just box the first answer and then...
Okay, so if you're going to box this, why would you bother rationalizing then, I guess is the question. Right, because then if you do it right, great, you don't get any marks for it, but if you do it wrong, we have to deduct marks. So why waste the time, right? Just leave it. Leave it. That's why the book doesn't rationalize. You probably already noticed sometimes the answers aren't. It's because on the exam you don't have to. Surprise. This was a 4-mark exam question from a few years ago. So the first mark came from getting whatever fraction add up to 11 pi on 12. Again, there's many answers. This is just one. There was a half mark for each of these values in here. The third mark came from getting down to the sign, and a full mark for going to the cosecant. So you get a full mark just for flipping it. So 4 marks. Last one, number 7. Are we proving? Nope. What are we doing? Solving. So you need to put on your equation hat, take off your identity hat, because if your brain thinks it's identity, you're going to want to start by putting that line. That's not what we're doing, we're solving. So this is exactly what we did last unit, except you wouldn't have been able to do this one. In fact, you would have cried if I'd given you this one. You would have been like, what? There's 4 functions and a 5x and a 3x? No, I can't do it. No, and you didn't know how to do it. Now you need to look at the patterns. You have a sine, cos, sine. Okay, look at your formula card. Does anything go with that pattern? Sine, cos, sine. So what we can do is put in the other half of this identity. The left-hand side would be sine of there's the offer, agree, disagree. Okay, so that's just sine alpha minus beta, because it's the minus up here. Let's simplify within the brackets. This is not hard. 5x minus 3x, not that hard. Now there was one like this on the review, and it was interesting to me is who came to ask, well, what do I do with the 2? Who just didn't bother to do the question, and who do I know just copied it off somebody else because they didn't understand it. So if there's a question on the review, you probably want to figure out how to do it. There's no point in either leaving it blank or just copying from someone because you're not going to understand it. What we're going to do for now is just ignore the 2. Pretend it's not there. Don't even look at it. Don't glance in its direction. Completely ignore its existence. What would we do with this if the 2 wasn't there? Sine x equals 1, and how would we solve that? Oh my God. X equals little unit circle, sine value, 1 unit, pi over 2. And what I'm going to do is just carry that 2 down to here. I just carried it down to the next step. Whoa, okay, woeing. Woeing, I'm woeing, yes. Okay. What the 2 actually means is 2 revolutions of the circle. It means we've gone around twice. So what we have to do now is just give the second revolution of the question, and that's just finding the positive coterminal to the first answer. So when there's a 2, we find 1 positive coterminal. If there was a 3, we would find 2 positive coterminals. If there was a 9, we would find 8 positive coterminals. That's all the 2 means. So what is the positive coterminal to pi on 2? Okay, so I'm just going to make a note. This was just the positive coterminal, because this means 2 revolutions. So 2 here means there's 2 answers here. If this was a 3, we would do it again and have 3 answers. If this was a 4, we would do it again and have 4 answers. But we're still not done. I want to solve for x. I don't want to solve for 2x. How do I get rid of the 2? So I'm going to divide this by 2, which means I divide both sides by 2. So left-hand side, those 2's are going to cancel and just give me x, and that's what we're trying to solve. How do I divide fractions? Okay, so a little imaginary 1 here, so I'm going to flip it and then multiply. Don't shout it all at once, I'll get confused. No, one at a time, really. Pi over 4 is the offer. Okay, second one, same thing, imaginary 1. And what's always the last step we do with any trig equation? So we look up here and we just check. Are those both between 0 and 2 pi? There's our answers. Okay, so just reviewing, the only thing that's different from last unit is we had this 2 here. All that means is you've done 2 revolutions of the circle, which means you take whatever your answers are and find the positive coterminal. And then at the end, just divide by whatever the number is in front of x. That's it. That's sum and difference identities. Let's just review what we did with the examples, because there is a lot in this, and I'm going to stop taking